Hello everyone, welcome to our channel. Today we are going to discuss another problem from the CSCS problem set, that is multiplication table. So without wasting time, let's discuss what the problem says about and how we are going to solve this problem. So the problem, as we can see, is saying find the middle element when the number in an n cross n multiplication table are sorted in an increasing order, and we are given n is going to be odd and we have to find the middle number. Okay, so the problem statement seems clear. Let's discuss what the problem statement actually. So we have a n cross n multiplication table. So multiplication table is, let's suppose we have 1 2 3 1 2 3. Multiplication table would be 2 2 3, so it would be 4 6 6 and 9. So this would be our multiplication table. So now we are going to find the middle element. As you can see, our n goes till 10 raised to power 6. So, and total number of elements would be n square. So our our brute force approach of finding each and every element and then going towards finding the middle element would give us a TLE, because there are n square total number of elements. So that would be not a solution that we are looking for. So let's see what is the optimized solution that we can say for that. So let's see. So the total numbers that we can say are ranging from 1 to n square. These are the total number of elements, and we know that when we sort these elements, so the middle element would land up in n square plus 1 by 2th index. This is where our middle element would be in the position, and we need to find the element which is at this position. Okay, so how we can say, if we know all these positions 1 till n square and we find a middle element, let's suppose our middle element, let's suppose our L is this and R is this. We are going to apply binary search for every middle element. We would check the count of numbers less than equal to mid, and that count is, when this count is equal to n square plus 1, then we return that element. I guess that is what might be, you have to be clear with this part, because how we can say that our count should be n square plus 1, because our middle element would be at the position of n square plus 1 by 2, and the elements that are on the left of this, our answer, would be less than or equal to answer. So here on this area we would be applying our binary search on. So let's write the pseudo code of how our binary search would look like. It would be, our L would be starting from 1 and R would be starting from n square, and then we would be writing a while where left is less than R, and our mid would be L plus R by 2, and then we would be an if of count. Our count, we would finding the count, and if less than the target position is what we call it n square plus 1 by 2. If this is less than this, then our left is equals to mid plus 1, else our right is equals to mid, and finally our answer would be equal to left. So let's now code up this solution. Now we are coding up, and let's our input in, and we get the n as input. We defined our left has to be 1 and our right is going to be n into n, and our target would look like target would be t, it would be r plus 1 divided by 2. Okay, now while L is less than R, int mid would be equal to L plus R by 2. We got the mid element. Now if, let's suppose we defined a countf function let's count numbers. Let's say we count numbers. We give it as int and mid is less than target. Then our left would be equal to mid plus 1, else our right would be equal to mid, and cout L would be answer. Now let's write the function for this. Int count numbers, int and int mid, int count equal to 0. Now I want you to focus us at this part, like how we are counting the numbers less than this. So for int I equal to 0, I less than n, I plus plus, we would be checking for count plus would be equal to minimum of mid divided by I comma n. So as we know that a multiplication array would be row cross column, so we are dividing it by a row and then we are checking it which would be the minimum for that, and this would be giving us the count for all the numbers less than equal to mid, and finally we would be returning the count. Now let's check for the base test case that we have. So base test case is 3. Okay, so there is some compilation error. Okay, so our target, okay, it would be T. Okay, so I guess we have made some mistake in this. Let's, oh okay, so our I should go from 1 to n, not from 0 to n. Yeah, yes, this is change, and let's submit this problem. Let's see if it's get accepted or we get any. Yeah, it's get accepted, and this is how our solution would look like. And let me know what another solution you want or want me to discuss the problem on in the comment section, and please like, share and subscribe the channel for more such videos. Thank you.